Hello everyone. Good morning. Am I audible? Yeah, perfect. Okay. So let's begin with the session, guys. Okay. Hmm, yeah. Okay. So what did we discuss in the previous session here? Probably from last three sessions here, we were doing something called as Java libraries over here, right? So we were going to talk about something called as Java libraries. So we understood what are Java libraries, okay, what are the predefined packages we have, what is object class, what is the speciality about it, and three important methods under that. Okay, what is toString equals hash code, okay, and we also understood how do we store objects into an array and what is the importance of toString, okay, and we also understood something called a singleton class. Okay, so we are done with this in the past three sessions here. In today's session I am going to talk about a very important topic here, and that is nothing but string over here. Okay, so what is the topic I'm going to cover today? I am going to talk about something called as string over here. What is a string basically? Okay, so string is nothing but it's a predefined class, okay, in java.lang package here. Okay, so we all know that string is a data type here, but internally string is a predefined class. Predefined class meaning it is already existing. Okay, once we download jdk and try to work around with that, right? So string is already existing class here, present in java.lang package here. Okay, and this is also, okay, final class here. This is also a final class, meaning string class can never be inherited. Why? Because if a class is final here, we cannot inherit it, right? So therefore string is a predefined final class which is present in java.lang package here. Okay, and one more most important point here which we have to add here is, okay, string class is, okay, immutable in nature. Okay, immutable means it cannot be modified or it cannot be changed. Okay, that's the reason we call string as immutable in nature. The string class is immutable in nature. Immutable means cannot be modified. Mutable means can be modified or can be changed. Okay, so string class or string objects are immutable in nature here. Okay, and then here, okay, there's one more point which I just want to add over here. String will also behave as a non-primitive data type. Do you all agree with this process here? 100%. It's a non-primitive data type as well. How? Because string is a class and it is also behaving as a data type here. Therefore, it's a non-primitive data type here. Why? Because the default, I mean, it's a class. So any class which behaves as a data type, it's non-primitive. And what is the default value for a string class here? The default value for any class type is null here. So the default value is null here. Okay, and it also implements certain interfaces here. Okay, what are those interfaces? Let us try to see here. See, I'll just tell you how do we look at the source code here. Okay, I open this Eclipse over here. We already have a project called as Java libraries. Under Java libraries, we have a package called as src. Under that, we have so many packages. So today, I'll create a new package, and that package name is, okay, I can create it as anything. I'll just have it as jspiders here. So I'll create a project and I'll create a package here. Okay, my screen is stuck here. I don't think so. Is everyone having the same problem, guys? Is there any problem with respect to the audio and the video here? Any issues with the the screen as well as my audio here? Okay, Deepthi, probably it's from your end. So cross check here. Okay. So yeah, right. Okay. So great, guys. Okay. So we just created a project called as Java libraries already created, and I just created a package called as JSpiders. Okay, that's it. Now right click and I will create a class here, new. And here I have to search for class. There's no class here, so click on other, and then you have to search for class here. Okay, and you can give any class name over here. I'll just give the class name as demo over here. Okay, I'll just give the class name as demo over here. Okay, so now here I have created a project, package and a class here. Now in this respective data here, I will have my main method. See, main control space bar. So when I tell main control space bar here, it means I am about to get my main method over here. So if I want to look at the source code of string class, okay, how the string class has been developed by Java people here, as I have told you, control on your keyboard, press control on your keyboard, hover on string. Okay, you can also write string, hover on string and click on string. It will take me to the source code of string class here. See here what is happening here. String is a predefined class. Okay, it's a final class as well. Therefore, string class can never be inherited here. Okay, and string is a public class, meaning public mean everyone can access it. Okay, but since it's final, we cannot inherit string class. Okay, and it also implements three interfaces here. What is it? It's serializable, comparable, and char sequence here. Okay, so this is what we are supposed to understand. And where is this string class present? If you just go on the top here, there is a package called as java.lang here. In that particular package, the string class is present over here. Okay, so this is all about the entire process here. If you want to look at the source code, you can have a complete look at the source code here. Look at the number of lines, the string class. Look at the number of lines here. 3167. Okay, you'll go mad. Okay, if you have to develop such a huge program here. Okay, but yeah, okay, this is all about the entire process over here. Okay, we are done with this entire part here. Okay, so what are the interfaces it is going to implement here? Okay, see here. What is string here? String is a predefined final, public final class. You can add one point called as public. Okay. String is a predefined. Predefined means it's already existing. Public means everyone can access. Final means we cannot inherit the string class. In which package is it present? Java.lang package. Okay. Got the clarity here? It's a predefined public and final class present in java.lang package. Okay. So string, in simple words here, okay, yeah, before that, okay, string objects are immutable in nature. What is that immutable here? I'll talk about it a bit later, okay, but as of now, just remember here, string objects are immutable in nature. They cannot be modified or they cannot be changed. It's immutable, okay. In other words, can I tell string is a collection of characters here? It's a set of characters or a collection of characters, and string also acts as a data type, okay, that behaves as a non-primitive data type, and the default value is null here. Got it? And then it also implements three interfaces. One class can implement any number of interfaces. So what are the three interfaces it is implementing? Serializable, comparable, and char sequence. Okay, so these are the three interfaces which string class is implementing. So this is all about the basic kickstart for string here. But now string, okay, string can be, okay, we can create string objects in two ways here. Okay, we can create what? String objects in two ways here. The first way is as a literal. Okay, we can create an object, string object as a literal, and the second way is with the help of new operator here. Okay, so string objects can be created in two ways, as a literal and with the help of a new operator here. Okay, so for example, see string, okay, s equals to, I write it as Java. So this is creating a string object, but with the help of a literal. Okay, this is like we are creating a string object as a literal here. And we can also create a string object with the help of new operator as well. How is it? It's simple. String, okay, object creation. String is a class, right? So we can create an object. See, string s equals to new string of, and we are supposed to pass the content over here. So whatever content I want to store, I have to write it down over here. So this is also a string object. This is also a string object, but we have two different ways of creating it here, because since string is a data type as well as a class. So therefore I can create string object in two ways over here. Okay, so when I go back to my theoretical notes here, okay, so the next point here is string objects can be created in two ways. as a literal with the help of double quotations and with the help of new operator as well. See, I've just given both the respective examples as well. Okay, so this is all about the string here. Got the clarity? But there are most important parts here, okay, which we are supposed to understand here. Okay, so string objects can be created in how many ways? We can create string objects in two ways here. Okay, that is with the help of a literal and with the help of new operator here. Okay, now we let us try to talk about a very interesting topic here. Okay, that is nothing but whenever we talk about string objects here, okay, that will get stored into a memory location, okay, and the string objects will always get stored into a memory location called as string pool here, okay. What is that memory location called as? That memory location is called as string pool, okay. So let me write it down somewhere over here at the bottom here so that you can easily understand here. So let me write it down somewhere. I'll write it down over here only. It is nothing but string pool here. Okay. So always the string objects will get stored into a memory location. And what is that memory location is called as string pool. That string pool is again further divided into two parts. Okay, it is further divided into two parts here. The first part here is we call it as a constant pool. Okay, we call it as what? Constant pool. And the second part is we call it as non-constant pool here. Okay, so string objects can be created in two ways, literal new operator. And all the objects will get stored into your memory location. And what is that memory location called as? String pool here. Okay, one is called as constant pool, another one is called as non-constant pool here. Okay, whenever I create a string object as a literal, okay, it will always get stored into constant pool, okay. And whenever I make use of new operator over here, okay, it will get stored into non-constant pool here, okay. So this is the second difference here. And the last part here is, okay, and the last part over here is, okay, duplicates are not allowed, okay, duplicates are not allowed with respect to constant pool, but duplicates are allowed with respect to, okay, constant non-constant pool here. So what is the meaning of it here? I'll just explain it in a beautiful manner here, okay, just wait for it. Okay, so first example over here, look here, I have string s1 equals to Java here. Okay, so this is nothing but a string object. Okay, actually speaking, it's a string object. All the string objects will get stored into a memory location. And what is that memory location called as? That memory location is called as string pool. Okay, but now I am creating an object with the help of a literal. So now where should the object get stored here? Is it constant pool or non-constant pool here? As a literal, if I create an object as a literal, always those objects will get stored into constant pool. So therefore, an object will get created here. Okay, what is that object here? That object is nothing but, okay, Java. Okay, and S1 is pointing to that respective object here. So if I create a string object as a literal, it will get stored into constant pool. Clear? Similarly, if I create a string object, see, string s2 equals to new string of, okay, and if I give it as SQL, okay, where will the string object get stored now? Sir, you are creating a string object with the help of a new operator. So always the string object will get stored into non-constant pool. If I create an object with the help of new operator, it's non-constant pool. So therefore, an object will get created and that object is SQL, and who is pointing to it? S2 is pointing to that respective object here. Clear? Similarly, I can have n number of objects, right? If there is no restrictions at all. So I will create one more object. String S3 equals to Java here. Okay. Now tell me, should the object S3 get stored into constant pool or non-constant pool? Should it get stored into constant or non-constant pool here? Okay, that is nothing but constant pool here. Okay, it's 100% that I have to store the string object into constant pool. But constant pool does not allow duplicates. This guy will never allow duplicates. But Java is already existing and I'm trying to store Java again here. So duplicates not allowed. So what will happen, the same object over here, okay, this is S3, that will get stored, that will be pointing to the same existing object here. Why? Because Java is already existing over here. So when I try to add Java over here, it will not point to a new object here because duplicates are not allowed. So to the existing object only, even S3 starts pointing here because duplicates are not allowed. But in case of, okay, in case of new operator, string S4 equals to new string of, and if I create an object and that object is SQL over here, so since I am creating an object with the help of new operator, it is always non-constant pool. See, new operator that has to get stored into non-constant pool. Since duplicates are allowed over here, a new object will get created, okay, by the name called as SQL only. The object name is SQL and S4 starts pointing to that respective object here. So what did you understand over here? Okay, all the string objects, okay, string objects here will get stored into one memory location. What is that memory location called as? String pool here. That string pool is further divided into, okay, constant pool and non-constant pool. Okay, if I create a string object as a literal, that will get stored into S1, and if I create an object with the help of new operator, that will get stored into non-constant pool. Okay, duplicates who allows? Constant pool. Duplicates who does not, who allows? It's non-constant pool. Who does not allow? It's constant pool here. Okay, so this is all about the entire process here. Clear? If there are a few things which we are supposed to understand, we will try to understand. So there is one question here, sir, what if we change S1? Okay, what will happen to S3 here? Okay, good question actually. Okay, so now here in simple terms over here, that is why we call it as string immutable concept here. What happens when I reinitialize S1 here? Okay, that question I'll answer when I do immutable concept probably after 10-15 minutes here. Okay, all your questions, okay, I'll answer it at the last here. Okay, don't worry. Okay, but this is what we are supposed to understand here. So look at the process here. All the string objects, okay, are getting stored into a memory location here. Okay, what is that memory location called as? String pool here. And that string pool is further divided into two types. What is it? Constant pool and non-constant pool. So therefore, all the literal string objects will get stored into constant pool, and constant pool does not allow duplicates here. Okay, and string objects which we create with the help of new operator, where does it get stored? Into non-constant pool, and non-constant pool will always allow duplicates over here. Okay, so this is just the memory hierarchy which we are supposed to understand. A few questions which are posted in the chat box, I'll answer it a bit later, not immediately. I'll answer it in some time so that you'll have better clarity. Okay, so this is all about, okay, what is string, okay, what is the memory hierarchy over here. Okay, so we have got the complete clarity about it. Okay, so now since string is a class, okay, and it is also inheriting the object class, do you all agree with this process here? See, now when I consider a string class, see, when I consider string, string is a class here. It might be predefined class, it doesn't matter. But I have told you one important thing here. What is it? A string class or any user defined class, every class in Java here will mandatorily inherit the object class. So even string class is inheriting the object class here. Got it? But now, here we have one important topic to discuss. What is the topic? I have a car called as dem car here. I have a class called as car. Now I have my main method over here. So now I will create an object of car C equals to new car of. Okay, got it? So now similarly over here, I will also have, okay, a demo class wherein I am creating an object of string here. String S equals to new string of, and I am passing the content over here. Okay, So now guys, okay, be careful and answer me what will be the output over here. See guys, I have my main method, okay, wherein the execution will always begin from. I create an object of car and I am printing the object reference. I repeat, I am printing the object reference here. So what will be the output here? Just the car class. Okay, I'm executing the car class. I created an object of car and I am printing the object reference here. So what should be the output here? Think and tell me what should be the output. Simple, sir. When I try to print the object reference over here, implicitly it will call this toString method. And the toString method will always give the string representation of an object. So therefore here, I will get the output. See, look at the output here, beautiful output here. Did I get it as see jspiders.car at the rate some hexadecimal value? So when I try to print the object reference here, it is internally calling the toString method, and toString method will give the implementation as fully qualified class name at the rate hexadecimal value. You can also call it explicitly also. See, c.toString. Either you print the object reference here, it will implicitly call toString, or you might also call it explicitly, that is toString here. What is happening over here? We are getting the fully qualified class name at the rate hexadecimal value, right? But now, similarly, okay, similarly over here, I will try to print the object reference of S here. See, when I try to print the object reference of S, what do we expect here? When we try to print the object reference here, the toString method will get called, correct? So here, when I execute it over here, okay, I do not get the string representation. Rather, I get it as Java over here. Why? Because the string class is inheriting the object class here, and it has automatically overridden the toString method. Rather than giving okay the fully qualified class name, it has been overridden to give the actual content whichever I have passed over here. Got the clarity here? So see, toString method is overridden in the toString automatically. So when I just write it as toString, see, even if I try to do it implicitly or explicitly, I'll get it as Java here. Why? Because in string class, toString method has been overridden in order to give the actual content here. In car class, I have not overridden. That's the reason I'm giving the string representation. But in string class, automatically it has inherited okay the object class, and automatically it has overridden the toString method. That's the reason we are getting the content whichever I have passed over here. Done. Similarly, when I tell just observe one program here. I just wanted to explain something. So over here, I'll give you the clarity at the end here. Okay. When I tell c dot hash code, what did you understand here? Sir, every object will have a unique ID. So that ID is called as hash code. So when I execute it over here, I get the fully qualified class name. See, I get the fully qualified class name implicitly and explicitly, and I get a unique number. Okay. Whereas, okay, when I try to do, okay, the toString method, I mean the hash code of string, see, s dot hash code here, and I will pass a over here. I'll pass a over here. So now when I execute it over here, look at the output what we get here. Okay, look at the output what we get. I get it as 65 here. So what did you understand here? The hash code method was supposed to give a unique ID, correct? But now in string class, it is automatically overridden, okay, in order to give the ASCII value of the object which I have passed here. Hash code was supposed to give a unique number, but now in string class, the hash code method is overridden in order to give the ASCII value here. If you want to cross check, you can look at the implementation. See, press Ctrl on your keyboard, over on the hash code method, click on it. Once you click on it over here, see here, it has overridden the hash code method in order to give the the ASCII value. See, some H blah 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 blah, some lot of calculations is happening over here. That is string dot class file. Got the clarity here? Okay. Similarly, if you want to see toString, press Control, click on the toString method, click on it. See, the toString method is overridden in order to return the current object. So when I tell current object over here, whichever object I have passed over here, the same object will be printed over here. Got the clarity? So now the toString method was used supposed to give the string representation, but it is overridden in the string class to give the actual content. Clear? Hash code was supposed to give the unique ID, but now it is overridden to give the ASCII value here. Got it? So this is all about the entire process here. Clear? Similarly, okay, I will create two objects. Car C1 equals to new car of. Okay. Now I'll create one more object. Car C2 equals to new car of. Okay. Now what will be the output here? C1 dot equals C2. What will be the output, guys? What will be the output? True or false? Common sense, no? Okay. So when you execute a program here, I will get the output as false here. Why will I get it as false over here? The reason is because internally the addresses will get compared, or the hash code will get compared, wherein these are two different objects here, wherein the hash code is different, address is different. So since the default implementation is used to compare the addresses or the hash code, I will always get it as false over here. Clear? Understood, everyone? So we will get it as false here. Why? Because internally the addresses or the hash code will get compared here. Whereas, okay, similarly, if I create a couple of string objects, see, string s1 equals to new string of, and I am passing, okay, string of, I am passing Java over here, okay, and here also string s2 equals to new string of, and here also I'm passing Java over here. So now when I tell s1 dot equals s2, okay, now what is happening, okay, so it is supposed to compare the addresses of two objects, correct? S1 is one object, S2 is another object here. Okay, it is supposed to compare the addresses or the hash code. But since, okay, equals method is overridden in the string class here, it will not compare the addresses, rather it will compare the content here. It will compare the content. Meaning if the content is same, the hash code method will also be same. No, why? Because the hash code method is also overridden. Clear? So therefore, equals method was supposed to compare the addresses here. That's the default implementation here. But in string class, it is overridden to compare the content whichever I have passed here. Got it? So that's the reason over here I will get the output as true over here. Got it? So this is what I just wanted to explain what is string doing internally. So look at the notes what I have done here. Okay. String class has automatically overridden three methods from the object class here. Okay. It means string class is inheriting the object class. Do you all agree with that process? Why? Because you like it or you don't like it, you have to digest this part here. What is that part? String class or any class for that matter in Java here will mandatorily inherit the object class. So even string is inheriting the object class. So all the 11 methods from the string class, it is inherited. But string class has overridden three methods. What is it? ToString, hash code, equals method. Okay. So now ToString method, what was it supposed to do? ToString method was supposed to return the string representation of an object, that is fully qualified class name at the rate hexadecimal value. But in the string class, it is overridden in such a way the fully qualified class name I will not get. Rather, whichever object content I have passed, the same thing will be the output here. Got it? And the hash code method was supposed to return a unique number, a unique ID for an object. But in string class, the hash code method is overridden in such a way it will not give a unique number. Rather, it will give a unique ASCII value for the object whichever I have passed here. So it is supposed to return a ASCII value here. And then equals method was supposed to compare the addresses of two objects. Correct? It was supposed to return the addresses. I mean, compare the addresses of two objects. But in string class, the equals method is overridden in order to compare the content of both the objects here. So this is what, okay, we are supposed to understand. Clear? So the most important interview question is the string class inheriting the object class? Your answer is a big S. Okay, string class, is it inheriting object class? Yes, obviously. And has it overridden any methods from the object class? Yes. What are those methods? ToString hash code equals. ToString is overridden to give the content which I have passed. Hash code is overridden to give the ASCII value, and equals method is overridden to compare the content here. This is all about the entire process here. Clear? Anyone having any confusion with the topic which I explained now? Okay? Anyone having any confusions as of now, guys? No? Okay, great. So now there are a few questions here. I shall try to answer it before going ahead. Okay. So what are those few questions here? I'll tell you. The first question was, yeah, this I was explaining that memory hierarchy. What if we reinitialize the S1 value here? Okay, what if it's Java here? What if I reinitialize S1? So that is immutability concept, which I'll be covering it in a few minutes here. Okay, just like 2-3 minutes here, I'll cover the topic. Okay, and here my voice is breaking. Absolutely no, I believe. Okay, so cross check. Okay, for whomever it's breaking here, probably the problem is from your end. Okay, and there's one more question. Can we create any other identifier type like literal, or only string is privileged like that? Okay, only string. Okay, only string we can do it with that. Okay, not everything, not other things we can do it. Only string is having that speciality about it. Okay, remaining things doesn't have it. Okay, so this is all about the entire process here. Clear? Now, what is the next topic which we are supposed to cover here? The next topic is, what are the constructors available in the string class here? Okay, there are many constructors available in the string class. Okay, many constructors which are available in the string class here. So here I create one class called as test here. Okay, under that I have my main method. Okay, so here, see here, string s1 equals to new string of, tell control space bar. Can you see here, so many constructors are available? So that is nothing but what? Constructor overloading. What is constructor overloading? So having multiple constructors, we have so many constructors over here. Okay, but we are concerned with only few. Okay, so here this is nothing but an empty representation of a string object. So now when I execute it over here, okay, see, I do not get any output at all. Why? Because it's just an empty representation of a string object. Because I have not passed any content over here. No. So here this is an empty string. So it's something similar to string s equals to empty string. Don't you think so? It's an empty string here? This is all about it. This is something similar to an empty string representation. Okay. So this is the first constructor here is, okay, empty representation of an string object here. Okay, empty representation of a string object here. Okay, second part here, okay, string s2 equals to new string of, and I can pass the actual content over here. I can pass a string object only. So I'll pass it as dinga here. So now here, when I try to print s2 here, what will be the output? Will I have fully qualified class name? Okay, or will I have dinga? Okay, what will be the output when I write it here? Okay, passing some set of characters. Okay, so here I'm passing some set of characters, meaning I'm passing a string data. So when I try to print the object reference over here, toString method will get called. Since toString method is overridden in the string class here, I will get the actual content whichever I have passed here. Okay, passing set of characters here. Set of characters, no, dinga is a set of characters, it's a string. So I'm passing a set of characters to the constructor here. And the third part here is, what is the third part? I'll tell you. Before that, see here, char c. When I tell char c, it's a variable declaration. Okay, c is of type char. It's a variable declaration. But as soon as I write brackets over here, it will become as a character array. Correct? Char array c here equal to open curly braces close, and here I will write it as j comma a comma b, okay, comma, and I'll also write it as a here. So this is a set of characters. See, this is a char array storing character values here, j, a, v, a as independent characters here. So now when I tell string s3 equals to new string of, and now if I pass this character array here, if I pass this character array to it, that will get converted to a string object, okay, and I will get the content here. See, when I try to print s3 over here, I will get the output as, okay, Java here. Why? The character array, whichever I have passed to the constructor, is getting converted to a string object over here. So the third set of constructor which are concerned over here is converting character char array into a string object here, for the clarity here. So these are the few constructors which we are supposed to know here. See, this is character array, so we are converting, okay, that character array into a string object here. Okay, this is character array, we are converting the character array C into a string object and trying to store it into s3. So when I try to print s3, that Java, which was a set of characters, will behave as a string here. Okay, so these are the few constructors which we are supposed to understand here. So what is the first constructor we saw here? That is nothing but empty string representation. Okay, meaning it's an empty representation of an object. Here I'm passing dinga over here, and here I'm passing an array, wherein that array will get converted to a string and I'll get the output here. So these are the three important constructors we have. As I told you, we have many here. You can explore on it. Okay. So this is all about the constructors which we have it in the string class here. Clear? And the next most important topic which we are supposed to discuss, okay, this is a mandatory question in almost all the interview questions. Okay, you might, I mean, if you are attending an interview for an MNC company or a startup company, doesn't matter, this question is always fixed here. Okay, very important question here. Okay, what they'll ask here, how string objects are immutable in nature, or they might also tell, explain string immutability concept. So if at all they tell immutable, you are supposed to explain how is it immutable here. Okay, so let me explain it over here. Okay, let me explain it over here, guys. Okay, so here, guys, all the string objects here will get stored into a memory location. What is that memory location called as? String pool here, correct? All the string objects will get stored into a memory location called as what? String pool here. Clear? Now that string pool is further divided into constant, non-constant, literal, new, new operator, duplicates, not duplicates, blah blah blah. Everything is there, but it works the same for everything. Now here, okay, concentrate here. Now when I tell string, okay, s1 equals to, okay, I write it as Java here. I write it as what? Java here. So what did you understand here? One object got created, and what is that object? That object is nothing but Java. Okay, that object is nothing but Java. And who is pointing over here? S1 is pointing to that respective object here. Correct? This is what we understood over here. Clear? Now here, similarly, okay, I will try to reinitialize. See, S1 equals to, now I will change it to SQL over here. So what is happening here? When we reinitialize a string object here, okay, whenever we are trying to reinitialize a string object, you know what happens here? Rather than modifying the same existing object over here, a new object will get created, okay, with the value SQL here, and then the old reference which was pointing to the old object will get dereferenced. Dereference meaning it will lose its connection here. It will get dereferenced here and starts pointing to the newly created object here. Got it? I repeat it. Understand? Whenever we try to reinitialize a string object, now I am doing it to web. Okay, it's a string object. Whenever we are reinitializing a string object. Rather than modifying the same existing object here, a new object will get created. Okay, with what? With whatever value I have passed. A new object got created by the name web. And the reference which was pointing to the old object gets dereferenced. Dereference meaning it will lose the connection to the old object and starts pointing to the newly created object here. And those objects, okay, which there is no reference pointing here, that all will get garbage collected. Garbage collected meaning all the unused objects here, meaning which does not have any reference pointing to it, will get garbage collected here. All the dereferenced objects are eligible for garbage collection. Garbage collection meaning the person called as garbage collector will automatically delete those objects. But in case of variables, right? See, when I tell int a equals to 10, there is a location called as a wherein it is storing 10 over here. When I reinitialize a equals to 20, the same value will get changed to 20. When I tell a equals to 30, the same thing will get reinitialized to 30 here. But that's not the case with respect to strings here. Whenever we try to reinitialize a string object, rather than modifying the same object, a new object is getting created. And the reference which was pointing to the old object gets dereferenced, and the reference will start pointing to the newly created object. This is how string objects are immutable in nature. Clear? This is called as string immutability concept here. String immutability concept. It's very simple, but it has a lot of weightage in your interview process here. This is what I have written it over here. See, when we reinitialize a string object, rather than modifying the same object, a new object is created. Meaning, whenever I'm trying to reinitialize, it is supposed to modify it. But in strings, since strings are immutable, okay, it does not modify the existing object. Okay, rather a new object is getting created, and the reference which was pointing to the old object gets dereferenced. Dereference means it loses its connection and automatically it gets garbage collected and starts pointing to the newly created object. So this is called as, okay, string immutable concept here. Okay, this is how strings are immutable in nature here. Got it? So this is what we are supposed to understand here. Clear everyone here? Okay, so you are just supposed to understand. So the example, one particular student asked me, sir, what will happen to S1 over here? See, in simple terms here, if I reinitialize S1 here, see, S1 equals to, if I just write it as web over here, if I'm reinitializing here, what happens, a new object will get created. A new object will get created by the name web here, okay, and S1 gets dereferenced here, and S1 starts pointing to the newly created object. So S3 is still pointing to Java now. Initially Java was pointed by S1 and S3. Now it is only pointed by S3 here because S1 is pointing to a newly created object. So here if I change to S1, it will not reflect S3. Why? Because new objects are getting created here. Got it? So that's what I just wanted to tell over here. So just, I'm just not writing it over here because I don't want to confuse it over here, but just understand the process. What happens when I try to reinitialize a string object? Clear? So this is all about the entire process here. Okay. In interview here, they'll tell, okay, string is immutable. Great. Okay. But do we have any mutable version of string here? Yes, we do have mutable version of string. And what is it? String buffer and string builder here. String is immutable. Great. Do we have any mutable version of string here? Yes. That is nothing but string buffer here and string builder here. Okay. So what is string buffer and builder here? How is it mutable here? I'll talk about it later, not today. Okay. But back of somewhere you should have this entire process here. Okay. So this is all about string and its respective specifications over here. And the only topic which I'm supposed to cover now is the methods present in the string class. Okay. Once I'm done, probably we're done with the entire session. We have many methods in the string class, but we need to understand a few important methods here. Clear? But whenever you come across mutable version of string, we are supposed to come across buffer and builder here. Okay, let us try to talk about a few methods in string class, and then okay, we'll have a brief summarization, and then we'll wind it up. Okay, so next 10-15 minutes, quickly we'll try to do it. Okay, methods demo here. I'll write a class called as methods demo here. Okay, now under that, I will have my main method. Okay, so you can create a string object in whichever way you want, as a literal or with the help of new operator. It doesn't matter over here in this particular scenario here. Okay, you can create it however you want it over here. Okay, so here I'll just create a string object. String s equals to, okay, I'll just write it as software developer. Okay, I'll just write the string object as software developer. This is also a string object. Okay, so now I have one method called as s dot. We have a method called as length method. When I try to talk about the length method, okay, it is used to count the the length of the entire string here. Just a moment, let me try to I'll be using it several times here. Okay, so that's the reason I am trying to copy paste it. Okay, so when I tell s dot length here, what should it return here? It should return me the length of software developer here. So what is the length of software developer here? It's 18 here. So if you count here, see, it's 4, 8, even the space is considered 9, then comes 9 plus 3 13, 13 plus 5 is 18 here. So the length of software developer is 18. Got it? So what is the job of length method? The job of length method is used to calculate the length of a string, and even a space should be considered here. We shouldn't ignore. See, if I give a couple of spaces over here, what will happen over here? I'll get it as 19. Why? Even a space is a character, even a dot is a character. We are supposed to, refer all of those. Got it? Done. Similarly, we have a method called as s dot, okay, to uppercase. Okay, I hope you got the clarity of it as well. Okay, immediately you got it. Similarly, we have a method called as s dot to lowercase. So now when I execute it over here, you can only easily understand. I need not explain anything. S dot to uppercase meaning the string is getting converted to uppercase, and S dot to lowercase meaning the string is getting converted to lowercase here. Clear? So that becomes, comparatively better here. Okay. So that way you can do it here. Okay. Similarly, okay, we have a method called as S dot starts with, I write it as soft over here. S dot starts with soft. Is it true or false here? I'm just writing, is the string starting with soft or not? So the output here, when I execute it, is false here. Can you tell me why is it giving it as false here? It's supposed to be true, no? Why is it giving it as false here? Think and tell me. It's supposed to, it's starting with soft, no? SOFT, it's starting with soft here. But why is it giving it as false here? Okay, it's supposed to give it as 2, no? The reason is Java is case sensitive. Okay, it is always uppercase SC. Now it gives true for the second instance. Why? Because Java is case sensitive, no? So we are just checking it is uppercase SOFT. So that is why we are supposed to be very, very smart enough in order to decide, okay, what will be the output here. Okay, so if we have starts with, we are supposed to have something called as ends with as well. Okay, ends with er. Is it true or false? It's supposed to be true. And s dot ends with, if I just write it as elopr, okay, so will it be true here? When I execute it, the first instance will be true, and then it will be false here. Why? ER is true, but ELOPR is false. Why? Because we're starting with uppercase E here, wherein it is lowercase e here. Got it? So that way we are supposed to differentiate between what are the method functionalities over here. Okay. Similarly, we have many, many methods over here. Okay, so we'll try to discuss all of those. And s system.out.println, I have to tell s dot, okay, I have a method called as contains. I will write it as, okay, dev. Okay, I'm telling if the string contains dve here. Is it true or false, guys? Is it true or false here? think and tell me here. Is it true or false here? Software developer, right? It's supposed to be true, right? Okay, it's supposed to be true. But here, when I execute it over here, okay, I'll get it as false here for the very first time. Why? Because I'm starting with uppercase. Oh, I'm so sorry. Oh, I made use of concat, is it? I'm so sorry. Contains uh, Dev. Okay, so here it is true here. Why? Because I'm starting with uppercase D here. That's the reason. Okay, see if you could closely observe, it's uppercase D. See, it's uppercase D over here. So that way we are supposed to identify. Okay. Similarly, as I told you, we have so many methods here. One more method, s dot concat. Okay. Software developer. Okay. I'll just write it as in ty. So what did you understand? Concat. Concat means it's going to append it. See, I'll get the output as software developer in ty. I want a space, no? So you can give a space here. S dot concat in ty meaning concat means combine. So software developer in ty. So the string gets printed as it is, and we are concatenating and printing it. That is ty over here. Got it? So these are the six or seven, yeah, seven important methods here. But we have many. Okay, don't worry. Okay, few more. Sys out. This is one of the most important methods. S dot char at index position 2 here. So I'm trying to find out the character in index position 2 here. So you have to tell me the output here. Let me copy paste it over here so that it becomes very easy for you all to predict it. So what will be the character present in index position 2 here? Okay, can you think and tell me over here? So I'm telling s dot char at 2. So what is the index position 2? I'm just finding what is the character at index position 2. It's 0, 1, 2. The answer is supposed to be F over here. Did I get the output as F here? Very good. I got the output as F over here. Clear? Similarly, sys out S dot char at index position 17 here. Now what will be the output? 17. Sir, what's such a huge thing? You have to calculate. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So, the index position is 17. That is nothing but R over here. So, I'll get it as R. Did I get it as R here? Because index position will always start from 0. So, the output will be R here. What if I give it as some random, 90? We don't have any index position as 90 here. Therefore, I get a huge exception telling java.lang.string index out of bound exception, meaning there is no index position as 90. So we get an exception over here. So you're just supposed to be smart enough and decide over here. Got it? So this is what we are supposed to understand. Okay. And then one more. S dot index of, okay, S dot index of, I'll write it as T. I want to find out the index position of T here. So char at is finding the character in that respective index position. But if I want to find out the index position of that respective character here, I have to make use of index of. And here I'll give it as D here. So I'm just making use of two characters. Tell me index position of T. What is the index position of T? 0, 1, 2, 3. Okay. Oh, you have to be smart here. See, it's 0, 1, 2, 3 here. So the output is supposed to be 3 for, T here and 9 for developer here. See, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 here. For D for 9 here. Okay. So this is how we are supposed to understand the entire process here. Okay. Now here there's one question here. Sir, what if I have duplication, sir? Okay. S dot index of, okay. I am finding the index position of E. But there are multiple occurrences, sir. E is present twice, sir. Thrice. Oh, 4 times it is present, sir. But which occurrence will it consider, sir? It will always consider the first occurrence over here. So what is the first occurrence over here? It's 7. So always 0, 1, 2, 3, 4, blah, 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 till 7 here. If there are duplication of characters here, it will always consider the first occurrence here. So if you want the second occurrence, third occurrence, fourth occurrence here, you have to write the business logic for it, your own logic. Java does not give the logic for everything. Okay, it doesn't spoon feed. Okay, so you have to write your own business logic for getting the the index position of all those characters. That you can take it as an assignment and also do it. Okay, you have to write your own business logic here. Clear? Similarly, I have a method. See here, string. Okay, I'll take it as a equals to. I write it as Java here. Okay, I write it as Java, and the string b equals to. I write it as Java here. Okay, and I'll write it as string c equals to. Okay, Java again here. Okay, now. So what am I trying to do here? You are supposed to answer here. Okay, you are supposed to answer. See, sys out. I tell a dot equals b here. True or false here. A dot equals b. Is it true or false? You can just tell TF here. Okay, that would be better. Okay, a dot equals c here. What should be the output? First one, a dot equals b. I'm just comparing the content of two things here. So now, initially, when I execute it over here, I will get the first thing as false and then true here. Why? Because Java is case sensitive. A is lowercase j and b is starting from uppercase j. So when I tell a dot equals b, okay, it's just checking for case sensitivity also. So here I get it as false over here. Okay, and here I get it as true over here. Why? A and C are same. See, lowercase j, lowercase j. Clear? If I want to ignore the case sensitivity, see, if I want to ignore the case sensitivity, I have a method called as a dot equals ignore case of b here. So when I tell equals ignore case, okay, it is just comparing for the content. It doesn't matter if it's uppercase or lowercase here. Now the output will be true here. See, now I got the output as true. Why? Because here we are not concerned with the case sensitivity. We're just concerned with the content over here. So that way it becomes very, very easy in order to understand. Clear? This is all about the entire process over here. Clear? I hope you all got the clarity about how do we work around with this respective methods here. Okay. Similarly here. Okay. Now, last part. Okay. Just don't kill me. Okay. Few more minutes. Okay. We'll be doing it here. I'll tell string x equals to. I'll just write it as hello dinga here. Okay, I'll just write the content as hello dinga. Now here I'll tell, okay, sys out x dot, we have a method called a substring of 3. What did you understand? When I tell x of substring of 3 here, what did you understand? Can you tell me here? Any idea? So the content is hello dinga, right? So now let me try to open paint here. Okay, so now, so my content is, oh, just a moment. See, it is, okay, it's hello dinga. Okay, so H E L L O space and then D I N G and A. So this is nothing but, okay, the content here, correct? Even a space should be considered, guys. Okay, so this is nothing but the content, and the index position will always start from 0 1 2 3 4 5 6 7 8 9 10. So here I have told x dot, okay, this is nothing but x substring of, what have I passed here? Substring of 3 here. Okay, substring of 3. So when I pass a single integer input, it will consider as the starting point, meaning from the third index position, okay, till the end point here, I have to consider the string here. Till the end point, I have to consider the string. So the output will be loading here. So now when I execute it, look at the output here. Will I get the output? Did I get the output as loading here? Yes, I got the output as loading here. Why? Because we are giving the beginning index position here. Similarly, x dot substring of, if I give it as 7 here, what will be the output here? Okay, if I give it as 7 here, think and tell me. From the seventh index position, I have to consider from the seventh index position till the last ending point here. So the output will be INGA. So we are supposed to consider from the beginning index is 7 till the end point. Okay. So here it's supposed to be INGA. Did I get the output as INGA? Yes. Okay. We got the output as INGA. Similarly, okay, one more minute, sys out x dot substring or I give it as 2 comma 7 here. What will be the output here? I'm giving the starting point as well as the ending point. So what should be the output over here? Okay, I'm giving 2 comma 7 here. So think and tell me, if I give it as 2 comma 7, what will be the output? 2 comma 7 here. You tell me the output. Okay, so here I have to start from second index position. Okay, I have to start from second index position and I have to end it till 7. Okay, 7 meaning it's still I, but we shouldn't consider the end point here. We have to traverse it till 6 only, because if I give the end point over here, it's up to the end point. Up to the end point meaning we are not supposed to compare the end point here. So it's just before the end point here. So it is LLO space D here. So the output is LLO space D here. Did I get the output as LLO space D here? Yes. So this is why I did this particular method here. Substring is calculating a small string within the entire string. When I give the endpoint here, we are not supposed to compare the endpoint here. We are not supposed to consider it. It's always up to the endpoint here. This works similar in Python as well. Okay. So x dot, one more good example. I'll start from 4 and end it till, okay, and I end it till 10 over here. 4 comma 10. Now you have to tell me here. Okay, what will be the output? When I give it as what? 4 comma 10 here. So if I give it as 4 comma 10, sir, I have to consider from fourth index position. But since I have given the endpoint as 10 here, I have to consider it till 9 only, because it will act as endpoint. So it's O space ding here. It's O space ding here. So when I execute it over here, did I get the output as O space ding over here? Yes. This is what we are supposed to understand. Clear? So these are the important methods which we have with respect to, okay, string class here. So probably we are done with many methods here, but few methods are length to calculate, oh, some import statement I've done. Okay, you can ignore it. Okay. So length, to calculate the length, two uppercase, two lowercase, converts to uppercase, converts to lowercase, starts with, ends with, to check if it's starting or ending with the specified substring. Contains, it checks, oh, if that string is there or not. Concat, appending. Okay. Char at, used to find out the character in that respective index position. And index of is used to find out the index position of that respective character. And then equals and equal ignore case we know, and then substring also. Okay. So these are the important methods which we have with respect to string over here. Clear? This is all about the entire process, guys. Okay. So anyone having any confusion over here in today's session? So what have we done in today's session here? We just completed, this is what we are supposed to understand over here. So very important part here. Okay. So now let us try to discuss here. Okay. So there is one question here. Sir, in an interview here, is string a class or a data type here? Okay. String is always a class which can also behave as a data type. That is nothing but non-primitive data type. In an interview, if they ask here, you are supposed to tell string is a class, but it has the speciality to behave as a data type as well, wherein it will behave as a non-primitive data type. Why? Because it's a class. That's the reason. Okay. So we understood what is a string here. Okay. And we also understood what are the two ways of creating an object and what are the memory locations over here, constant, non-constant. Okay. And it has overridden how many methods? 3. ToString was supposed to give the fully qualified class name, but in string class it's overridden to give the content. And hash code is supposed to give the unique ID, but it gives the ASCII value. Equals method was supposed to give compare the addresses, but now it compares the content here. And we understood how is it immutable, and what is mutable version of string? buffer and builder, string buffer, string builder. We'll talk about it sometime later. Okay. And then we also saw the important methods in the string class here. Okay. So this is all about the entire process, guys. Okay. I hope we are done with the session for today here. So any questions in today's session here? Please do let me know. Any questions here, guys? You want me to repeat any concepts? Great, guys. Okay, so I'm done with the session for today. Okay, so hopefully from tomorrow we would be starting with exception handling. And exception handling is one of my favorite topics. Okay, and a very, very important topic for your interview perspective. So today will be the last day wherein I'll be uploading the videos here from tomorrow because I didn't want to have that continuity mismatch. So from exception onwards, I'll not be posting any videos here. Okay, so if you want to learn, make sure attend the session. Okay, if at all there is any genuine reason here, we'll try to find out some solution for it. Okay, so great, guys. Okay, so we shall wind up a session for today and catch up tomorrow. Okay, so thank you all, take care, bye bye.